This is final review part 2 video, going through all the problems on the final review quiz part 2 that we were given in MOM or in class. So you want to make sure that you have a copy of that in front of you because I won't be displaying all of the questions on screen. First one, we are given a graph and we're asked to find some limits. So first one is limit as x approaches -1, and then the little negative sign in the exponent indicates from the left. So we want to take a journey getting to -1 from the left. So we would need the left-hand side. So we're going to follow this line till we get to -1, and the y value that matches up when we get close to -1 would be 2. For the second one, we're getting to -1 but from the right now. So we're going to use the right graph, go to -1, and the y value that matches up is -1. Now the limit as x approaches -1 of f of x doesn't exist because from the left it's 2 and from the right it's -1. Now f of -1 is an entirely different question. That one's just asking what is the value of y when x is -1. So when x is -1, the value of y would be +1 because that's where the closed dot is there. All right, number 2. We are asked to find the limit as x approaches 4 of x squared minus 2x minus 8 over x minus 4. So the first thing you always try with limits is just plugging in the value. But I can see that if I plug 4 in the denominator, I get 0. So I have to try something else. And the next logical thing to try here would be factoring. So this is going to be x minus 4 and x plus 2. We see that the x minus 4's can divide out, and I'm just left with the limit as x approaches 4 of x plus 2. So again, we can try plugging it in. 4 plus 2 is 6. Number 3 is another graph, so I'm going to bring that in. All right, it wants to know the value where f of x has a horizontal tangent. Now there could be more than one, so it should say values. But for a horizontal tangent, we're looking where we're going to draw the tangent line and it's going to be flat. Like right here at -4, if I draw a tangent there, it's horizontal. So -4 is one of my answers. And this happens again right here. We get a horizontal tangent line, and that's at 7. Number 4 is another graph problem. We want to match the derivative of this function with the graph of the function. So all you have to do is think about what the tangent lines are doing. So along here, on the left side here, where I'm drawing in yellow, my tangent lines are all negative. So that means, and then at -2, of course, it's at 0. So on the side here, I'm going to start graphing this. So it's negative until I get to -2. And what happens there, it's 0, and then it starts to become positive. So it's going up until we get to 1. So here's 1. And yeah, let me straighten this out a little bit. Should be more parabola-like. And at 1, we see that our tangent lines are going to be, the slope of the tangent lines, I should be clear about that. So here from -2 to 1, the slope of the tangent lines is positive. And then the slope of the tangent lines are negative from 1 on. So we're going to go negative again. So the derivative of our graph is looking like a parabola that's opening down, and that would be the third option from your MyOpenMath worksheet or MyOpenMath assignment. Finding derivatives. We have f of x is 6x squared minus 5x minus 36. So the derivative, it's pretty cut and dry. The 6 times 2 makes it a 12. Subtract 1, we just get x. And then this would be a 1, so it's minus 5, and then x to the 0 is just 1. So negative 5 times 1, or times 1, or just negative 5. And then the 36 just becomes a 0. So we get negative 12, oops, not a negative. Or we just get 12x minus 5. Number 6, we want to find the derivative of negative 8 square root of x plus 9 over x to the 6. Let's change it up and make it negative 8x to the 1/2 power plus 9x to the negative 6. And then we can use our power rule. So it's going to be negative 4x to the negative 1/2 minus 54x to the negative 7. Now you can rewrite this as negative 4 over the square root of x minus 54 over x to the 7th. Either one of those answers is fine. Let f of x be 8x plus 5 minus 11e to the x. Then the equation of the tangent line to the graph of f of x at a point 0, negative 6 is given by y equals mxb, and we need to find m and b. So let's start with the derivative. That's going to be 8 minus 11 e to the x. So if I plug 0 into that, I get 8 minus 11 e to the 0, which is 8 minus 11 equals negative 3. This means that my slope at 0, negative 6 is negative 3. Now we just have to find b. So y is negative 6. X is 0, so 0 times negative 3 plus b. Well, that gives us b equals negative 6. So m equals negative 3, b equals negative 6. Number 8, suppose a product's revenue function is given by r of q equal to negative 3q squared plus 900q. Find an expression for the marginal revenue function, simplify it, and record your result in the box below. Be sure to use the proper variable in your answer. Marginal revenue just means take the derivative. So it's going to be minus 6q plus 900. Easy peasy. Number 9, we're using the product rule. So we have 3x to the 9th minus 6x to the 5th times 6e to the x minus 7. Derivative of the first would be 27x to the 8th minus 30x to the 4th. Then all of that times the second. We're going to add that to the derivative of the second, which is just 6e to the x multiplied by the first. And that's how you leave your answer. No need to distribute or FOIL. Number 10 is g of x equals x squared plus 3x minus 5, that whole quantity, times e to the x. If we want the derivative, again, we need to use the product rule. Derivative of the first is 2x plus 3 times the second plus the derivative of the second times the first. Now note that you can switch that order of these two, or these two to be, for that matter. And then they want you to simplify that one. So both of them have an e to the x. We can take e to the x out, and we're left with 2x plus 3 plus x squared plus 3x minus 5. Combining like terms in that, we get x squared plus 5x minus 2. Number 11, g of x is equal to e to the x over 5 plus 4x. G prime of x, we need the quotient rule. So the derivative of the top times the bottom minus the derivative of the bottom, which is just 4, times the top, all over the bottom squared. Now my open math will want you to simplify this so we can take an e to the x out, and we're left with 5 plus 4x minus 4 all over the bottom squared, which is just ex times 4x, 1 plus 4x, or 4x plus 1. And the bottom stays the same, 5 plus 4x all squared. Number 12. F of x is equal to 5x plus 8 all to the negative 1 power. We want to find the derivative. This will require the chain rule. So my power still comes down in front, and I still subtract 1. So I get negative 1 times 5x plus 8, that whole quantity to the negative 2. But then I need to multiply by the derivative of the inside, which is 5. So I get negative 5 times 5x plus 8 to the negative 2. Another chain rule. F of x is equal to 4e to the negative 5x to the 7th power plus 3x to the 8th power. Now, of course, the derivative of e to the x is just e to the x. But when you have a power other than x, you have to multiply by the derivative of that power. So that quantity would be negative 35 x to the 6th plus 24 x to the 7th. Be very careful entering that in the computer. You want to make sure that this whole exponent is there. 14 is asking for a ddx of 6 ln of x. Well, the derivative of ln of x is just 1 over x, and we have that 6 there, so it's just 6 over x. Number 15, probably need a whole for. We're given the function f of x equals negative 6x cubed plus 6.39 x squared plus 163.5336x minus 7.55. We want to know where it's increasing, decreasing, and where it has a local max. So start with the derivative, which is negative 18x squared, and then 2 times 6.39 is 12.78 x, and then plus the 163.5336. And the negative 7.55, the derivative of that is just 0. Luckily, we can use our calculator program to find the zeros. So we'll set this equal to 0 and solve for x, and we should get 2 different values. So program quad, A is negative 18, B is 12.78, and C is 163.5336. The two values are negative 2.68 and 3.39. We'll need to draw a number line and plot both of those points in the right order. And I'm going to pick a test point before, after, and in between. So negative 3, 0, and 4 will all work. So we want to know what f prime of negative 3 is. F prime of 0, well, f prime of 0 is pretty easy. That's just the 163.5336. And f prime of 4. So I'm going to go ahead and go into y equals, and I'm going to put in negative 18x squared plus 12.78x plus 163.5336. Then I'm going to do second graph to get my table. And right now it's not set up for me to put my own values in, so I'm going to go to second window, and instead of having the independent be auto, I'm going to select ask and then go back to second graph, and I'm going to put negative 3 in, giving me negative 36.81, and I'm going to put 4 in. That's a negative 73.35. So on the interval, the first interval, it's negative. So if the first derivative is negative, then that means the function is decreasing. In the middle, it's positive, so my function is increasing. And then on the end, again, we're negative, so my function's decreasing. So for the first question is increasing on the open interval. We need more room. Oops. Yeah, that's what I want. Okay. So it's increasing in that middle interval, so that would be negative 2.68 to 3.39. It's decreasing. All you need is the endpoint, so from negative infinity to a negative 2.68 for the first blank on your paper or in MOM, and then it's also So it's, well, I'll just write it out. It's negative infinity to negative 2.68. And then also the 3.39 to infinity. So it's going to have a local min or max where you're changing from increasing to decreasing. So we go from, starting from left to right, we're going from decreasing, going down, to increasing. So that's a minimum. But then we go from increasing to decreasing, giving us our max right there where it's changing. So that is happening at where the derivative is 0, and that's at 3.39. So there's a max at 3.39. And there's a min at the negative 2.68. Not that you needed that for the problem, but might as well let you know. And that's it for that one.